Hello everyone, good morning. I am Dr. V.R. Chinchamalatpure, Hutatma Rashtriya Art and Science College, Asti, District Wardha. My topic of my research is synthesis and characterization of BaBiO3 film. Abstract of this manuscript: BaBiO3 thin film were synthesized onto the silicon substrate by the molecular beam epitaxy method using an oxygen radical source in order to oxidize the film. The oxygen radical source was operated at RF power at 600 watt. The background pressure during the deposition was 5 into 10 raised to the power minus 5 torr. The scanning electron microscopy of BaBiO3 shows that the film as deposited is opaque and is revealed a high degree of porosity. After the annealing, crystallization increases. The X-ray diffraction shows that the diffraction peaks are sharp with increasing temperature, which enhance the crystallinity of the film. The FTR spectra of BaBiO3 anneal at 600 degrees Celsius shows the intense band at the edge of detection is assigned to BiO mode. Now, introduction of this research. The BaBiO3 has a perovskite crystal structure with an order alternating Bi3p and Bi5p at room temperature. This charge disproportions and ordering coupled with tilting of BiO6 corners shared octahedra results in a cell with a monoclinic symmetry. It was reported that the BiO3 film only has a out of phase tilting. There have been a number of reports on the compound BB, especially polycrystalline BaBiO3 ceramic doped with acceptors such as potassium, lead, and other additives for the potential use in high temperature superconductor application. BaBiO3 were sintered in oxygen to obtain the single phase with a monoclinic symmetry as suggested by high resolution X-ray diffraction. X-ray photoelectron spectroscopy confirmed the presence of bismuth in two valence state. Among the various methods, BaBiO3 can be prepared by hydrothermal precipitation, combustion method, and BaBiO3 film grown using pulse laser deposition, chemical vapor deposition, metal organic chemical vapor deposition, polymer precursion method, molecular beam epitaxy method. This molecular beam epitaxy method shows relatively high deposition rate, so some efforts have been made to prepare BaBiO3 film by molecular beam epitaxy method. Now, although BaBiO3 film can be made by flash evaporation, the deposition rate was too low for preparation of multi-layer ceramic chip capacitor. In this present work, BaBiO3 film were deposited using molecular beam epitaxy method. The purpose of this study is to evaluate the variation of composition of sources and film with processing condition and to prepare BaBiO3 film by this method with high deposition rate. Now, present method was used to prepare BB ceramics using the precursor of BaCO3 and Bi2O3. The powder were mixed together in proper ratio, ground using a vibratory mill for 6 hours and dried overnight in an oven. The powder were then calcined in alumina crucible at 700 degrees Celsius for 24 hours and then milled and dried. Green pellets in the shape of this disc were prepared by cold pressing uniaxially at a certain pressure and then sintered in oxygen at 800 degrees Celsius for 12 hours. Now, the characterization surface morphology of scanning electron microscopy of BaBiO3 film as deposited is opaque and it reveals a high degree of porosity. Surface roughness increase in comparison to the optical quality film. After annealing, crystallization increases and significant changes in surface morphology takes place. Now, second one is the X-ray diffraction. This powder X-ray diffraction result shows that the BaBiO3 nanoparticles are amorphous after the first step, thermal decomposition. Thus, at higher temperature, 500 degrees Celsius, the BaBiO3 film fully crystallizes. Now, this shows that after 500 degrees Celsius treatment, all diffraction peaks can be assigned to the BaBiO3 phase without any indication of other crystalline nature. The diffraction peaks are broad, indicating the formation of nanocrystal. The average crystal size can also be calculated at 60 to 64 nanometer from the device error equation. Now, last one is the FTIR. This shows the infrared spectra of BaBiO3 film on silicon substrate as a function of temperature at 500 degrees Celsius and also at 600 degrees Celsius and 700 degrees Celsius also. The broad and strong band observed at 470 degrees centimeter inverse characteristics of TiO bond infrared analysis gave some important information about the phase transformation of the film on silicon substrate. The infrared absorption band SiO2 is found at 1090 centimeter inverse because the oxide layer on silicon subsurface grows during thermal treatment. It is also detected at this temperature that BaBiO3 is already formed. Now, conclusion of this manuscript. This method presents in terms of added degrees of control in the manipulation of thin film properties for the preparation of thin film which exhibit the highly uniform nanostructural texture and grain size. The BaBiO3 deposited on silicon substrate were studied by surface characteristic. The XRD BaBiO3 Si indicate the enhanced crystallinity of the film with annealing temperature at 500 degrees Celsius. The infrared spectra of BaBiO3 film on silicon as a function of temperature at 500 degrees Celsius. The broad and strong band observed at 490 centimeter inverse at the temperature of 600 degrees Celsius characteristics of TiO band. Thank you very much.